right, good morning, class. How's everybody doing? Good. Everyone looks very bright-eyed in the sheet here, which is very nice. So at the end of lecture today, you will hand in your homework sets to Shannon. So this is going to be the first question from the theoretical exercise. And just to remind you, the second question is due on Tuesday. And for the second section, I want you to just follow the step-by-step guideline. So think about the first assignment as setting the context, and the second step-by-step guideline is really giving you the procedure for doing it, right? So if there's any way in which those two things differ, defer to the step-by-step guideline for walking you through that, okay? All right, great. All right, so who can remember what we did last class? Who can give us a quick recap of the last class? And so what I want to encourage you to do is after you finish a particular lecture, just go back home, read over your notes, and make a brief summary to remind yourself of what it is that you're learning, right? Because that's going to be a very good way to review for the midterm, and it's also going to help you to pick up from where we left off in the last class. So anybody remember what we did last class?
We looked at present value,
Yeah.
and if somebody has, for example, $100 today, how much will they have in the future?
Right. So we looked at the present value. And the present value is a way for taking a stream of income and converting it into dollars today, right? And we use the present value for what purpose? Tom, right?
See how much you have now and how much you have.
Exactly. And how do we connect that to education?
We connected it by the go through school, how much we have after getting a job, degree, and whatnot, or by saving all the money that you would spend going to college and getting a normal, regular high school degree job, figuring out how much you make then, how much you could have by the end of your schooling if you went to college.
Exactly. So the thing with getting an education is for the first 4 years, or how many ever years you are getting an education, you're not going to be earning anything. So you could have been in the labor market earning whatever the wages of a high school graduate would have been earning. So you're foregoing those earnings. Moreover, if you don't have financial aid, or if you're paying to come to college, you're also paying some cost into those periods. And you're paying that cost today, right? Now the hope is that in the future you're going to make more money. And so as a way of doing this cost-benefit analysis, what the present value allows us to do is to take this stream of costs going to college, the first 4 years, and the benefits, which are going to be the differentially higher earnings that you're going to get once you have graduated, and to say, how much is this stream of income worth to me today? And to do an analogous calculation for the stream of income that you would get if you only had a high school degree for the rest of your life, right? And now when we think about, well, how much is the stream of income as a college grad worth to me, versus how much is the stream of income as a high school graduate worth to me, we can do a step-by-step comparison, right? And what's one of the key parameters that's going to affect how much schooling somebody gets through the present value?
Discount rate?
Exactly. What's the discount rate?
I guess it's how much they value a dollar tomorrow versus a dollar today, or how much more they value a dollar today than a dollar tomorrow.
Exactly. So the discount rate is going to tell us, is going to allow us to convert a unit of consumption today into a unit of consumption tomorrow into a unit of consumption today, right? And so we worked through the example of the interest rate. If I had a dollar today and the interest rate was R, tomorrow I would have 1 plus R dollars, right? And so if you gave me a dollar today, I would be indifferent between a dollar today and 1 plus R dollars tomorrow, right? Okay. Any questions from last lecture? Okay. So we're going to continue on with this. So we're going to talk about how much education is enough. And what we're going to do today is introduce the Mincer earnings function. And this is a relationship between years of schooling and experience. And then we're going to talk about how we can, and this is a very important earnings function in economics. And so there have been like thousands of papers ran on running this regression to measure what are the returns to schooling. Because the returns to schooling are going to be very crucial in terms of determining how much schooling you get. If the returns to schooling are high, do you think people are going to be more likely or less likely to go to school? If the returns to school are high, do you think people are going to be more likely or less likely to go to school? They're going to be more likely, right? Because they're expecting higher future payments from going to college, right? And after we do that, then what we're going to talk about is the role of ability in determining the returns from school, right? So to set a little bit of a groundwork for this, imagine that you had someone like a Mark Zuckerberg. Who in here knows who Mark Zuckerberg is? Okay, what is Mark Zuckerberg famous for?
Dropping out of Harvard.
Okay.
And
What sets him apart from all of the other Harvard dropouts, like Bill Gates and
And Facebook.
Facebook? So he created Facebook, right? So Mark Zuckerberg is a junior at Harvard, and he's thinking, I can create Facebook, right? Or I can get a Harvard degree. Right? Why is Mark Zuckerberg among the 1% of Harvard students who drop out of Harvard?
Because he has the ability to produce a good / service that is going to make him billions and billions of dollars, whereas the other folks do not, and they have to go earn a living like the rest of the folks.
Yeah, so I mean, like, so in a sense, if we ignored ability, we would say this guy's an idiot. If I just told you, person X was doing a college degree at Harvard and they dropped out, you'd be thinking, what an idiot. Like, he or she could have had a Harvard degree, but now they just are like a high school person with some courses completed at Harvard, and everybody's gonna look at this person and say, wow, like, you just dropped out, like, you couldn't finish college, there must be something wrong with you. But in fact, it turns into, for the folks that are dropping out of Harvard, it's like, these are the guys that are high ability. What if you see someone that was in, let's say, a community college and they dropped out? What assumptions do you think people make about them in the labor market?
Think of that community college.
Yeah.
Probably get a job and get maybe legs.
So we just talked about the dropouts at Harvard, folks more likely thinking that they're going to be the high ability people. It's among the Harvard graduate students going to be the high ability kids that drop out because the opportunity cost of like going to Harvard is like, the opportunity cost is just too high of staying in school, right? For the kids who are dropping out of community college, what do you think is going to be the priors or the beliefs of the labor market about those folks?
Low ability.
Low ability. Why do you think low ability?
Because you can't make it through community college without much actual ability to start with.
Right, if you can't make it through community college, you don't have much ability to start with, right? But if you're getting into Harvard, it's like already you're in the tails of the distribution. So maybe you have something even better than Harvard that you can walk away with. And so now you see that taking into account ability is very crucial for understanding what the returns are going to be to an additional year of schooling. And so we're going to talk about the role of ability in the returns to schooling. What we're going to do when we get here is we're going to fix, let me pause on that for a second. And then the third thing we're going to talk about is education as a signal to the labor market. Who remembers from the very first introductory lecture when we talked about signaling, what signaling is?
Whether someone's college degree indicates something about their natural ability after they decided to go to college in the first place.
Exactly. So the idea here is going to be, even if you didn't learn anything in college, there could still be value to going to college, right? Because going to college could signal something about you to the labor market. In particular, it could signal the fact that you were good enough to get into Clemson, a phenomenal school, right? And so just that in and of itself is like, okay, this guy or this gal is pretty good, right? They got to Clemson and they were able to take the coursework and they were able to go through the coursework. They're diligent, they showed up on time, and they had the patience to like wait out 4 years. And so just the fact that you go to college says a lot about you because the types of people that are selecting into college, for them it's probably easier to sit in a room and listen to a professor lecture for an hour and 50 minutes, right? For some people, they would just be like, I can't do this at all, right? And so we're going to talk a little bit about education as a labor market signal, okay? And all of these are going to be connected. Any questions before we get started? Okay, so we're first going to start with how much schooling is enough? This is our question, right? Now, first what I want to do is introduce this Mincer earnings function. So it's called the Mincer wage equation. right? And I'm gonna write out the equation. So it's gonna be the natural log of the wages is gonna be the natural log of the wages if you had no schooling whatsoever. So this is what this W naught is. Plus gamma times S, where S is the number of years of schooling. So W is gonna be wages. Given, so W is going to be wages given the level of schooling and experience, right? So that's this W here, okay? S is going to be the number of years of schooling. Right? And then we're going to have plus beta 1x, where x is years of experience. So you can think about years of experience as how long you've been on the job, right? And then we're going to introduce a quadratic term in years of experience. And the reason for that could be that, let's say you were on the job for 1 year. For 0 years, right? You're just on the job for the first month. The difference between somebody who just started a job and somebody who's been on the job for 18 months, do you think that's going to be a big difference or a small difference? Why do you think it's going to be a big difference?
Because that's 18 months of experience that that person has that the new one doesn't.
Okay. Now, what about somebody that's been on the job for 19 years versus somebody that's been on the job for 21 years and 21 and a half years? What about the difference between those two guys? Do you think it's going to be a lot or small?
Probably small to get to that point.
Exactly. And so what's happening is, like, for a job, a lot of the learning is going to be happening initially because you have to come there, you have to meet the people, you have to know how the organization works, you have to learn your function, and there's a lot of specific learning to the task that you're going to be doing, but a lot of specific learning as well to the type of company culture, right? So you have to learn that on Clemson on Fridays you wear what color? And you go to football games sometimes or all the time? Right, and so like somebody coming in doesn't know that, right? But it's like with experience, it's like somebody that's a senior, and if they don't know that you wear orange on Friday, you look at them and you say, what have you been doing all the time at Clemson? But if it's a freshman, you just say, okay, this is just a poor freshman. They're gonna know in like, a week or 2 weeks, right? And so the idea behind this quadratic experience is that for the same change in experience, but at different levels of experience, the gap in the wages could be dramatically different, right? So that's the reason for having this quadratic. And so this is a standard regression. This is called the Mincer wage equation, right? And so your earnings is going to be a function of the years of schooling and experience. And you can think about this W0 as being the wages that somebody would earn with the 0 years of schooling. This is the wages earned if schooling equals 0 and experience equals 0. Any questions so far on this? And is everybody familiar with the natural log? Okay. So whenever we write log in economics, it's always the natural log. So that's log base E, where I used 718 or dot, 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 dot. Yeah, everyone knows, who knows the natural log? Just raise your hand. The exponential function, e to the x, yes? Okay, right? Okay, good.
So whenever you write log, it's natural.
Yeah, yeah. So whenever I write log, that's just log base E. Just so that you know. All right, good. So, yes.
Where for S is that?
This is a gamma. Okay, so let me talk about the coefficients. Okay. Let's go. Let's talk about interpretation of the coefficients. And that actually leads into what we want to talk about. So this gamma term is going to tell us how one additional year of schooling is going to affect log wages. Does everybody see that? So for example, if gamma is positive, an additional year of schooling is going to have what kind of an effect on log wages? Positive, right? Good. What if gamma is negative? Okay, good. All right. So to figure out what the effect of schooling is on wages, what we do is let's look at the derivative of log wages with respect to schooling, right? What is the derivative of log wages with respect to schooling?
One.
Can you say it louder? It's gamma, right? Because schooling is wages, log wages is just linear schooling, so it's just going to be gamma. Does everybody who understands this raise your hand? Who does not understand this raise your hand? Okay. What's the derivative of gamma times s with respect to s? Okay. So do you understand that? Okay, good. Okay, good. So everybody gets this, right? Okay. Now, what is the derivative of log wages with respect to s? Just on the left-hand side, if you didn't know what's on the right-hand side. How do we take the derivative of a log? Chain rule. Uh-huh.
We do whatever that is.
Right, so it'll be 1 over wages, right? Times what?
One, right? You did derivative.
No, but wages are a function of s. So we have to multiply by what? So we do 1 over what's in the parentheses times what? The derivative of what's in the parentheses with respect to that, right? Does everybody remember this? So let me put this on the side. This is an example. If we have some function h of x, if we have some function log of f of x, right? And we take the derivative of that with respect to x. By the chain rule, this is just going to be 1 over f of x times df dx. Does everybody remember this? This is what you did in your first homework. Anybody unclear on this? Who understands? Raise your hand. Yeah, okay, good. All right, let's apply the same principle here, right? So we take the derivative of the log of w, right? W is not the same as s, right? So we have to do 1 over w times the derivative of w with respect to s, right? And that's going to be equal to gamma. And the reason why I'm going through this is to interpret what this parameter is going to be. Okay. Now we think about this dw ds as being how do the wages change with s, right? And so we can rewrite this as 1 over w times a small change in the wages over a small change in the s. Right? Does everybody follow this so far? The reason being that if we had a wage profile that looked something like this, right? Let's say this was wages and this was years of schooling, and I wanted to figure out what the derivative was at this point here, we would draw a tangent line here. And we would say, what's the change in the years of schooling versus the change in wages? And the slope at this point here, dw ds, would be approximately equal to how much do wages go up as we change schooling by a little bit. Does everyone follow this? Who does not understand this? Raise your hand if you understand. Raise your hand if you don't. Right? Okay. And the reason why we're doing this is we're going to say, okay, we're going to approximate this derivative here by saying, what's the change in wages for a change in the years of schooling, where the change in the year of schooling is just 1, right? So we're just going down here. Okay. So like, suppose that delta s equals 1, which is just saying for 1 additional year of schooling, how much do wages change? Okay, that's the question that we want to ask ourselves, right? And so delta S is equal to 1. And we want to find delta W, right? So i.e., we want to find delta W change in wages if delta S is equal to 1. If we have one additional year of schooling. Right? Everybody with me so far? Who's, yes?
What about, so it's delta S, not change of S? Or change
Delta
of
S is the same thing as a change in X. So whenever you see delta in economics or math, like typically it has the interpretation as like a change. And so this derivative is, this D and delta are the same thing. So delta actually is the Greek letter for D. And so that's why typically we use delta for this, right? So df dx is, how does the change in X vary with a change in Y? Okay, everybody with me so far? Okay, so let's call this equation 1. Okay, so this is our answer. So set delta S equal to 1 and solve for delta W, which is the change in wages. So this W here is what are the wages right now, right? What are the wages currently, given your current years of schooling? And then we're saying what's for a change in schooling by 1 year, what's the change in wages? Okay. So if we do that, what we're going to get from equation 1, set delta S equals 0 and solve for delta W from equation 1. So what we're going to get is what? What are we going to get? When we set delta S equal to 1, what are we going to get from equation 1?
W gamma.
Hold on. We're going to get, we set delta S equal to 1. So what's the first thing that we have in equation 1? Like literally just enter it. 1 over W times what? Times delta W is equal to what? Is equal to gamma. So this is delta W over W is equal to gamma. What is delta W over W? What's the mathematical interpretation of that? It's the percentage change in W, right? So we start with the wage W, and then we get an additional year of schooling, and so now we make W plus delta W. So delta W over W is the percentage change in the wages, right? Do you understand it, Toro? Okay. You look confused. Oh, what don't you understand?
Like, I know you got the one plus chain of S1.
Okay.
Where did you plug that one?
Okay, so in equation 1, delta S is equal to 1. So then we get 1 over W times delta W divided by 1 is equal to gamma. So we look here, we get 1 over W times delta W